Patricia Dunleavy, and this is my Lab 11 last at-home lab for Physics 2211. So, the main objective of my lab that I chose was to observe and model an elastic collision. In this case, between a soccer ball and a wall was my observed data. And my main result was the observed data and model data do not match very well, and this is likely because of external forces and some transfer of kinetic energy to internal energy, meaning that the collision is not perfectly elastic. For my video, I modeled the motion, as I said, of a soccer ball hitting a ball and rebounding. And here you can see my ball and tracker. My roommate kicks it and then it rebounds at another angle. I chose the origin arbitrarily because it didn't really matter in this case, and I wanted something that would have both x and y motion so that I could observe that. And I calibrated the length using the length of the door, which was 1.07 meters. So to look at the physics principle behind my video, which is an elastic collision, in an elastic collision, kinetic energy is conserved. So because of this, there is no change in internal energy. So the initial kinetic energy equals the final kinetic energy of the system. And while the collision that I chose was not perfectly elastic, I decided to model it using an elastic collision because the mass of the door is about 55 kilograms, which is much greater than the mass of the soccer ball, which is 0.43 kilograms. Which means that its results will be very close to that, which means that the results are close to that of an elastic collision. So to show how this is true, for the momentum principle for the collision, the momentum principle says that the change in momentum over change in time is equal to the work done on the system. But for the short duration time of the collision, we can effectively assume that there are no external forces. So the final momentum of the ball plus final momentum of the door equals the initial momentum of the ball plus the initial momentum of the door. And so I assumed that the speed of the soccer ball doesn't change significantly, so its final momentum is just equal to the opposite of its initial momentum. So the momentum principle becomes the following equation that you can see. So basically, we find that the momentum of the door finally is twice the initial momentum of the ball. And then when we solve for the velocity of the door, we find it is twice the ratio of the mass of the ball over the mass of the door times the initial velocity of the ball. But when we take that actual quantity of the mass of the ball over the mass of the door, that's equal to about 0.008. So we know that the numbers are not that large. So when we multiply them by 0.008, which is 8 thousandths, the total amount is going to be very small. So the rebound velocity of the door is negligible, and this is why we don't see the door move, because its velocity is so small that we can't see it. And then the kinetic energies, because the velocity of the door is very small, its final kinetic energy is very small, and so because of this, it's not exactly zero. So therefore, the soccer ball does lose some speed in the collision, meaning it isn't perfectly elastic. So then I modeled this elastic collision in VPython, and by basically using the same time interval of the video, which was 0.7 seconds, and I made a wall and a ball, and found their positions relative to the origin from the tracker data, as well as the initial velocity of the ball I found from the tracker data using the first two data points. And then to model the collision, because in an elastic collision, the momentum is just the negative. The final momentum is just the negative of the initial momentum. I put that in here so at the point when the ball hits the wall. So here you can see the program running. So you see the ball bounce and then it immediately rebounds. So here are the graphs of the X position in the red and the Y position in the green. Okay, so here is the comparison of the X position data. The blue is the data from Tracker, and the red is the data from VPython. And you can see that this is not perfect. at the end they deviate a lot, but in this area near the collision, the deviation is less. Um, and then here the Y position again deviates really greatly. The blue is again the data and the red is tracker. It's very, very different, you can see. So the reasons, so to compare the data and the model, while the model represents a perfectly elastic collision, it's clear that the data represents a somewhat inelastic collision. So some of the speed of the soccer ball is lost, which isn't accounted for in the model. And also the material of the soccer ball, rather than an elastic collision, it allows for more deformation of the ball, which wouldn't happen in an elastic collision. So this further reduces its elasticity. And other forces such as the friction of the carpet change the motion of the ball. And also the angle of collision with the wall is not exactly 90 degrees, which also changes the motion of the ball. So finally, overall, this model isn't the best way to represent because there's no such thing as a perfectly elastic collision in nature.